Hello, welcome to Mr. Johnson Math and Science class. In today's physics class, we'll be doing work. This is my email address, and here's my digits. You can WhatsApp or call me via these digits. Okay, in our topic on work, I'm just gonna take the definition and I use some diagram to explain something. So we say work is said to be done whenever a force moves its distance of application, a distance in the direction of the force. Okay, what do I mean? Assuming I think I want to do some kind of diagram right now. Okay, so let's say let's say we had a drum of oil right here. This is a drum of oil. Just standing here, okay. And then maybe it was an empty drum. So we had this man right here. He actually he applied a force by probably throwing an object. So he threw that object on this drone, and when he threw this object on this drone, the object smashed the drone, and then the drone fell down here. So let me just make the diagram look very much realistic. You understand? So when he smashed this let's say maybe it's a green drone. Let's just take time to make our work look good. So this is a green drone. Okay, now let's fix some key information based on this diagram. Okay, so this man smashed this drone. You understand? So when he smashed this rubber made some distance. So he left here and moved towards here. So there was a movement here. So in moving here, it extended some distance. Are you getting me? And then a force was actually what? A force was applied on this. So this is the force. The force from this was applied on. Maybe we can use another example. Say the man pushed the drum, but here he used something to smash the empty drum, and then the drum came here. So let's go back to our definition. We say that a work is said to be done whenever a force, so this is the force, moves its distance of application, a distance in the direction of the force. So this object was here and then is now moved to this part. In so doing, you say a work has been done. So maybe it has moved, let's say 4 meters or 3 meters. So this is the meter, and then maybe a force of 10 newton. You understand? A force of 10 newton or 20 newton or 15 newton have been applied to this drone. So because of that, we say that what? A work has been done. You understand? And the SI unit of work is joules. Okay, let me just go ahead and write some basic things down that will really guide us. Okay, so for work done, just like we have in our diagram, is force F times distance. Force times distance. But because of the kind of our works in physics, work done is known as force times the distance. We use S. So this distance, I think, don't worry, just in a moment I'm going to write this. So WK is equal to F times S. So this S is the distance, and that is going to be the general formula we're going to be working with as regards to solving for the work done. Work done equal to force multiplied by distance. Okay, and we say that the SI unit of work is joules. Okay, so let's continue and solve questions as regards to this. Okay, so what is the work done when a force of 10 newton displaces an object through 5 meters? Now, one thing you need to know in physics is that the units should tell you what they are. So now I am seeing, I think I just want to highlight this. Now I have Newton. Newton is telling me force. I also have a meter, and that is telling me distance. And the question is asking me what is the work done. So I don't know what is the work done. So analyze your question before solving. That's going to help you a lot much. So let's come over here. They ask what is the work done. So work done in this particular scenario is not known, because when someone is asking you what is, it means the person doesn't know what is it. And then force, so let's say F is what? 10 Newton. What again do we have? An object, so we have distance S, and that is what? 5 meter. So now we have the basic things we can actually work with. So just go ahead and say work done in the system, work done is equal to force times distance, right? Okay, so work done, we don't know it, you're solving for it. What is force? Force is 10, and then distance is 5, so 5. So 10 times 5 is going to be giving us 50, right? So 50 joules. Please don't forget to put your units, always add it. So the final answer we had here is that this will amount to 50 joules, and that is our final answer. So let's go to the next question. Okay, what is the distance attained by an arrow if the force applied is? So let's say, I think I want to draw, but I don't know how cool my diagram is going to be. So let's say we have a man here, and I pray my diagram is going to be cool. So this man, he had an arrow. So this is his bow. He shot an arrow, or he's shooting arrows. So let's say one of the arrows he shot has attained the particular distance. So let's say this is the arrow he shot. Let's get our colors to make it look cool. So this arrow has moved from this point. Yeah, let's say he's shooting series of arrows, and this particular arrow has moved from here where he shot it and up to this point. So it has undergone some what is the distance? So it means that the distance the arrow has covered, let's say either we take the horizontal distance, or the distance is not specified, and you know is distance is not a vector quantity, so the distance oftentimes are not specified except displacement. So the distance it covers from here up to this point, that is the horizontal distance, is what we are asked to solve for. So we don't know it, we can call it x or call it a variable, or we can also see that the distance from here, covered from here to here, is the unknown, so we can call it x. Hope this makes sense to you. Okay, so let's analyze our question and go ahead and solve them. So we said, what is the distance? It means that s is not known. They don't know what is distance s attained by an arrow if the force applied, force is F, so 8 Newton, and if a work of 32 joules. So we already have work done. The work done, I use WK for work done, is 32 joules. So let's put down our formula, which says that work done is equal to force times distance, and what work done is what? 32, equal to, let's remove the unit and solve. So force is what? 8 multiplied by distance is unknown, so let's just call it s. 32 times 32 equal to 8 times the x, that is distance. It's a variable, just becomes 8s. So what do we do from here? We divide both sides by divide both sides by 8. So have that 32 over 8 is equal to 8s over 8. So 8 can cancel 8. Let's check 32 divided by 8, 4. So 32 here is 1, and here is 4. So therefore s, which is distance, is equal to 8 meter. Distance is measured in meters, so the distance attained by this particular arrow when it was short was what? 8 meters. Okay, so I have another question to solve. Let's go ahead and make sense out of it. It says if an engine force of 1000 newton, so because we are seeing newton, what comes into our mind? Force, right? So F is 1000 newton, pulls a boat 50 meter. Because of meter, we know the distance, so let the unit always help you to know what you're talking about. So 50 meter is distance. Calculate the work done. So WK they don't know, so the work done is not stated. So let's say work done, WK, which is work done, is equal to what? Force times distance. And what is force? Force is 1000 multiplied by what is distance? Okay, distance is 50. So let's do that here. 1000 multiplied by 50 is giving us 5000, okay, 50,000 joules. Okay, so we have here 50,000 joules, and that's just that. So our final answer here amounts to joules. Okay, so that's our final answer. Okay, try on your own. You also have one question to solve. Make sure you solve this question. I can pause this video and copy the question down and solve it. Okay, thank you so much for being a part of this class. I really do appreciate. My name is Mr. Johnson. I can tutor you one-on-one anywhere in the world for your maths and sciences. So just an inch away from me, hit my digit and we'll talk. And I promise you the rest of the story concerning your maths and sciences is going to be a complete turnaround. Thank you so much for being here and watching this video. I really do appreciate.